Now we still have to talk about sample size. If you're trying to estimate the average weight of all the pink elephants in the world, and you haven't yet gone out and found any pink elephants, you might want to know, how big a sample do I need? How many elephants should I weigh? If you're doing a poll or a survey, you want to know how big a sample you need. How many people do you need to survey? So the question of how big your sample has to be depends on two things. It depends on the margin of error. That is, how narrow do you want your confidence interval to be? Do you need to know the average weight just to within plus or minus 1,000 pounds, or 100 pounds, or 10 pounds, or what? And the other thing it depends on is the confidence level. Do you need to be 95% sure that the interval you calculate contains the actual population mean? Do you need to be 99% sure? What confidence level are you working with? So here is the formula for the sample size to find the confidence interval for the mean. N equals z sub alpha over 2 times sigma over e, and then the whole thing is squared, and then whatever that formula gives you should be rounded up to the next whole number. That's because sample size has to be a whole number. You can't have fractional pink elephants. We already know what the z sub alpha over 2 and the sigma stand for. The e stands for your margin of error, or the maximum error of the estimate. So that's how precise you need your estimate to be. If you want to know the average weight of all pink elephants to within 100 pounds, then 100 is what you would put into the formula in place of E. So let's do some examples. To estimate the average age of the students at a college to within 2 years, with confidence level 99%, how large must the sample be if sigma equals 2.3? So for a 99% confidence level, your z sub alpha over 2 number is 2.58. You're given that sigma is 2.3. And you want to know to within 2 years, so E would be 2. So you put that all into the formula. And we need to calculate parenthesis 2.58 times 2.3 divided by 2, close parentheses, squared. The calculator gave us 8.803089. Now that can't be our final answer because I can't tell you to go out and find 8.803089 students. It has to be a whole number. And we always round up, because if we round down, we'll have a number that's smaller than what the formula gave us, and that might be too small. It's okay to have a sample that's bigger than it absolutely has to be, but it's not okay to have a sample that's too small. So to make sure the sample is big enough, we always round up, and in this case, that would give us 9. So the answer is you need at least 9 students in your sample. If you just need to know the average age to within 2 years, so it's whatever it is plus or minus 2 years, you just need a sample of 9 students. Okay, what if you only want the age to within 6 months? I want to know to within 6 months, what's the average age of the students at this college? So now z sub alpha over 2 is still 2.58, sigma is still 2.3, and what are we putting in for E? If you said 6, that's not going to be right, because if you put 6 into the formula, it's going to think you mean 6 years. So what's the age plus or minus 6 years? But we want it within 6 months, which is half a year. So the number we put in for E is 0.5, half a year, if the age is within years. So N equals 2.58 times 2.3 over 0.5 squared. Whoops, let's put that in the calculator and see what we get. 140.849, so 141. That takes a lot bigger sample. You need a sample with at least 141 students in it if you want to know the average age of all the students at the college to within half a year. What if you want the age to within 6 months, but you only need a confidence level of 95%? So that's going to change your z sub alpha over 2. You're going to be using 1.96. Same formula, but for a 95% confidence level, the z sub alpha over 2 number is 1.96. And let's see what we get from that. (81.288) and so on, and rounding up, always round up for the sample size, we get 82. So you would need a sample of at least 82 students. Okay, another example. It is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies would have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? Assume that sigma equals 10.1 chips. So first of all, notice this is a question about sample size. How many cookies would have to be sampled? How big does the sample have to be to estimate the mean number of chocolate chips per cookie? So we got our formula. We need to put in the numbers for z sub alpha over 2 and sigma and e. Now, I didn't show the z sub alpha over 2 for 98% earlier on that earlier slide, but I did include it on your notes. For a 98% confidence level, the number you use for z sub alpha over 2 is 2.33. So we're going to put in 2.33 times sigma is 10.1 divided by, what's E? Well, we want to know the number of chips per cookie to within 2 chips. So E is 2. Close the parentheses, square it, and the calculator gave us 138 point something. We round that up, and the answer is 139. So we would need a sample with at least 139 cookies in it.